Welcome everyone. Two circuits are displayed here as a circuit 1 and circuit 2. In a circuit 1, this capital P and capital Q, that is a 5 ohm, and capital Q is 10 ohm. These two are connected in series combinations, we can say. And an ammeter is also connected in series, which is measuring what is the current flow through the ammeter. And this series combination is connected to the supply E1 or battery E1, EMF of the cell. The potential difference V is connected, potential difference not, that is the voltmeter is connected across this EMF of the cell, and when this key K is plugged in, the current is flowing in the circuit. And it is shown it is that the reading of the ammeter A in the circuit 1 is 1.2 ampere. So if the reading of the ammeter A is 1.2 ampere, then that current passes through it. If this 1.2 ampere current passes through P, and 1.2 ampere current passes through Q also. Okay, because they are connected in series with the ammeter. So if it is, just try to understand that. Then what is the potential drop across this P? That is the current which is passes through P, that is the 1.2 ampere, and the resistance of the P, that is the 5 ohm. And if you calculate it, you get the 6 volt. Similarly, if 1.2 ampere current passes through this Q, then what is the potential drop across it? That is the 1.2 ampere multiplied by 10 ohm, and if you make a product of these two, you will get the 12 volt. So if I just draw this in the circuit, this is the 6 volt, okay, and this is the 12 volt. So 6 volt and 12 volt are the potential drop across the 10 ohm, and since we have considered this ammeter is an ideal one, so the potential drop across it, we considered it as a 0. And since no other resistances are connected here, so we can say whatever be the potential drop or the EMF of the cell, that is basically distributed in these two resistors 5 ohm and 10 ohm. So from that idea we can say E1, that is the EMF of the cell, it is nothing but the sum of Vp and Vq. So Vp is 6 volt, Vq is 12 volt. So as a whole we can say that is the 18 volt. 18 volt is the EMF of the cell. And this V, that is the voltmeter, is connected across this E1. So we can say the voltmeter will show the potential drop across the EMF of the cell is 18 volt. It may contain the internal resistances. If it is, then we can say V equal to E1 minus I R1. So we don't know actually what is the resistance of it. But it shows that if 18 volt is the potential drop across the cell, what is the available in the external circuit, that is the series combination of 5 ohm and 10 ohm, that is 18 volt. Okay, so the voltmeter shows the 18 volt. Now let us come to circuit 2. In the circuit 2, the reading of the ammeter A1 is given 6 ampere, and this 6 ampere is also flows through this 5 ohm. Reading of the ammeter 2, that is the A2, is 3 ampere. Okay, so this 3 ampere flows through this 10 ohm. So what is the potential drop across Vp? So Vp is the 6 ampere multiplied by 5 ohm. So we can say 30 volt is the potential drop across the resistor P. Similarly, the potential drop across the resistor Q, that is the VQ, which is 3 ampere, multiplied by the 10 ohm, that is 30 volt. And it should be. That is the potential drop across P, and the potential drop across Q is same because they are connected in parallel, and that should be equal to the EMF of the cell, that is the 30 volt. So in the circuit 2 and circuit 1, in the circuit 1 all the unknown quantities we have defined already, whatever been known to us. Just I am repeating here. EMF of the cell is 18 volt. When the key is plugged in, the voltmeter shows the reading 18 volt, and that current starts flowing. Which current? 1.2 ampere starts flowing through P1, through capital P, that is the 5 ohm, and the ammeter reading shows the 1.2 ampere. The capital Q, through capital Q 1.2 ampere flows. The voltage drop or the potential drop across P is 6 volt. Voltage drop or potential drop across Q is again 12 volt. Since ammeter is considered the ideal one, so the potential drop across it is 0. So the total potential drop is 18 volt. Now coming to circuit 2, in the circuit 2 informations are given. Reading of the ammeter A1 is 6 ampere. Reading of the ammeter A2 is the 3 ampere. So we have shown there. So when the ammeter, obviously the K1 and K2 should be plugged in. Okay. So when the key K1 is plugged in, when this circuit is in operating mode, at that time 6 ampere current flows through the 5 ohm, and the potential drop across it is 30 volt. 3 ampere current flows through this capital Q 10 ohm. Potential drop across it is 30 volt. These two were connected in parallel combination, and the potential drop across them are same. And since capital E2 is here, which is connected across parallel to it, so the potential drop across it is also 30 volt. That means the E2, the EMF of the cell which is connected in the circuit 2 is 30 volt. One thing I want to add, if you just plug in the K1 and plug off the K2, that means the current is only flowing through K1. It is also allowed because the circuits are connected in parallel combination. You may do this, that is the K1 is plugged off, that is through capital P, current is not flowing. K2 is plugged in through capital Q, the current is flowing. Then also the circuit is in operating mode, and 3 ampere current is flowing through the circuit. Okay, so we can say what is the total current of the circuit. Obviously it is 9 ampere. Okay, now it is 9 ampere when K1 and K2 both are plugged in. Okay, when K1 is plugged in, K2 is plugged off, then 60 ampere current flows through the circuit. When K2 is plugged in, K1 is plugged off, then 3 ampere current is flowing in the circuit. I am drawing this to the next page. That is, this is the 30 volt. Okay, this is the 30 volt EMF, that is the E2. Okay, when only the K1 is plugged in, K1 plugged in means K1, this circuit is operated, and plugged in means switch is on, plugged in. In that particular case, we can say the current is flowing through this capital P. What is this resistance capital P? The resistance capital P is 5 ohm. Okay, so this is capital P, and this resistance is 5 ohm. And in that particular case, obviously 6 ampere current is flowing, and what the ammeter A1 basically shows. When the K2 is plugged in, only, obviously when K1 is plugged in only, that means K2 is plugged off, and here when K2 is plugged in only and K1 is plugged off, then if I draw the circuit, then see, this is the 30 volt. Okay, the current obviously not flowing through capital P, so I am not drawing that. Current is flowing through capital Q, so I am drawing here this capital Q, and that is the 10 ohm, and the current is what? 3 ampere. Okay, when both K1 and K2 plugged in, when K1 K2 both are plugged in, then in that particular case we can say this is your E2 is 30 volt. Okay, it is 30 volt. K1 is plugged in. So capital P is in the circuit. Okay, capital P means 5 ohm. K2 is also plugged in. That means capital Q is also in the circuit. That means your 10 ohm. Through capital P, 6 ampere current flows. See the potential drop and resistance you will understood, and the ammeter verifies the same. 3 ampere current also flows through the 10 ohm. Okay, 30 volt divided by 10, 3 ampere, and the ammeter also verifies the same. Then 9 ampere current is withdrawn from the circuit, because when this capital P and capital Q are connected in parallel combinations, in that particular case the equivalent resistance drops, so more current is drawn from the EMF. Okay, so this is the full scenario of these two circuits. Thank you.